right, hello everyone. So I'm very excited to chat with you guys today. I have a lot of things to cover in a few minutes, but the first thing I'm going to do is try to convince you to contribute to open source and grow the PyTorch community, right? So how do we do that? I'm going to tell you a little bit of my backstory for this, right? So I actually started in the US military. So that was the first career that I ever did. I was going through Navy SEAL training and then spent a few years at a SEAL team where I got injured, right? And then from there, the Navy gave me two choices: leave the military or become a pilot. I was like, I'm okay. So I left the military and kind of figured out how to code as a way to have a next career. And what I quickly realized was that outside of public service, as a developer, I think that one of the main ways that you can get back to the community and kind of have public service is through open source, right? So if you're ever wondering how to grow the community and how to give back beyond your company and your personal interests, I think this is a main way. And that's what's really driven me and our company at the core, right? So when you use PyTorch Lightning, you're seeing a lot of those fundamental principles behind it as well. So I'm going to tell you a little bit about how this came about and what we're doing for GenAI right now. So there you go. So if you haven't tried PyTorch Lightning, I encourage you to do so. Here are some stats. So PyTorch Lightning has over 4 million monthly downloads today. Overall, 76 million downloads in the last few years. If you go in the open source on the GitHub repo, you'll see over 24,000 projects using Lightning, et cetera. I want to kind of frame this and put it into context a little bit. So Lightning actually started as a kind of personal project of mine in 2015, right? So in 2015, I was an undergrad, and I was working on computational neuroscience. And I wrote this neural network in Theano to train a model, and we had to publish at NeurIPS that year. And the model was taking about, 7 days to train one epoch of ImageNet. So I was like, well, clearly we're going to miss the deadline. That summer, TensorFlow had come out. And I was like, great. So I bought a bunch of 1080s, put together a bunch of machines on the lab, and then rewrote all that code into TensorFlow, right? And in that process, kind of made it a little bit agnostic so that you could try different ideas out. The problem that we had back then and still today is you write one project, you do some optimization like multiple GPUs, and then the next project you fork that, and then you change that, and then you fork that again and again and again, and now you're maintaining multiple GPU implementations in 17 different projects, right? Every single person here has run into this. So I was like, I don't want to do that. That's what Lightning came about. What's the standard on how do I go between research ideas and not change my code? Zero code changes, right? That's kind of what we introduced back then. And that stayed true for a while. Fast forward 2 years later, PyTorch came out, and I was like, oh, this makes a lot more sense. This is math, I can read it, there's a forward, there's a backward, great. Immediately converted it, made it a lot more agnostic, and then moved on with my life. Saved me a lot of time as a student, which is great. And then I started my PhD a few years later. And I was fortunate enough to do my PhD at NYU with a lot of FAIR members, so Yan LeCun and Kyung-Hun Cho, who were researchers at FAIR at the time. And then I joined FAIR a few months later, right? So about 2019 in the summer. And I'd open source Lightning before that to give people access to it. There, we were basically training models, self-supervised learning, so a lot of stuff has come out of FAIR recently on that. It's a lot of the work that we were doing then. And these were models on about 1,000 GPUs back then, 2019, right? And that's what Lightning came from. It was how do you train these massive models in the Facebook cluster at scale? And it just continued to grow from there. So these numbers come from a long line of legacy of actually working together with the PyTorch team as well, inside Meta, with working with Facebook engineers, working with people outside of the community, and a lot of you guys have contributed to it as well, right? And so it's really been driving a lot of the way that people can adopt Lightning super, super easily. Today, Lightning powers some pretty cool open source stuff. There's obviously a ton of other companies that I'll talk about in a minute. You can find it in Stable Diffusion. That's all powered by Lightning. Hyena, RWKV. A lot of kind of the latest research is using Lightning under the hood to train the models. We introduced a few things you guys are familiar with. So the first thing that we ever introduced was PyTorch Lightning. This introduced the trainer, right? So this is the first trainer ever created. We introduced the ability to go between CPU, GPU, and TPU with zero code changes, right? Today, that's become a standard in other libraries, which is great. But a lot of these ideas were really collaborations that actually we did internally at Meta to make these things happen. And then we also have Fabric for GenAI, where you can actually control the way that things are sharded. Torch Metrics, which a lot of you use. LitLama and LitGPT, which are harnesses for training LLMs as well. 40% of PyTorch pip installs also come with Lightning. Right? That's a huge percentage of the PyTorch installs as well. So we actually do work with a lot of the community. We're in over 10,000 companies today. So you can talk to I don't know, NVIDIA, Lyft, Uber, et cetera. All of these people are powering their training workloads and inference workloads with Lightning as well. You can bring your models. Bring your models from Hugging Face. Bring your models from Stability AI. We don't care where the models come from. Models are rockets. We're NASA. We're going to put them into space. We're going to make them run really fast, deploy them, all that stuff, right? This is PyTorch Lightning. I'm going to skip this, but at the bottom, you see the trainer. That's kind of the key to a lot of this stuff. At the top, this is just organized PyTorch, right? Then we recently introduced Fabric, where, so in the trainer, we had this, abstraction under the hood for many years called an accelerator that actually did the conversion between CPU and GPU. And then that accelerator basically became independent libraries after that. And so we formalized our own library called Fabric that takes that out and allows you to use it without the trainer, right? But that's been there since Lightning 1.0 in about 2020. Today you're going to find, sorry, I'm almost out of time here, but basically you're going to also find Lightning powering some of these things, Tiny Llama, the NeurIPS LLM Efficiency Challenge, and then obviously the kind of thing we talked about today for fine-tuning inference. Some of these things are based on the GPT. Anyways, we'll be around. Thank you, guys. And there will be another talk that talks to you about 2.1 and all the things that have been deployed there. Thank you.